Okay, let's continue with the inverse of the cosine function. Okay, and to get the inverse of the cosine function, its domain will be restricted and the y equals to cosine x. Okay, and let me sketch it roughly. Okay, on the coordinate system plane. Okay, and oops. Okay, and maybe okay, and the blue and is restricted area. This part is pi. Okay, and the +1 was -1. Okay, and the so y equals to capital C O S, that is the restricted cosine x. Okay, and so its domain will be 0 is less than or equal to x is less than or equal to pi. Okay, and that's the domain. Okay, domain, and its range will be -1 is less than or equal to y is less than or equal to +1. It's the range of restricted cosine function. Okay, and what can you say about this function? Okay, and it will be let me sketch it again. Okay, and it will be inverse sine x. Okay, and look at it. If the cosine 0 is 1, so cosine 1 will be 0. Okay, and so we'll go like that, and the cosine -1 will be, okay, pi, so it's like that. This is pi, this is -1, okay, and this point is plus 1. Okay, and this point is pi over 2. Okay, and this function is r cosine x. Okay, and we can also write it cosine of, and I mean that of course capital cosine of inverse cosine x equals to x, and for minus 1 is larger than or equal to x is larger than or equal to 1, and the inverse cosine of cosine x equals to x for 0 is less than or equal to x is less than or equal to pi. Right, and of course you can write if cosine theta equals to x, okay, you can write theta equals to inverse cosine x, okay, and if cosine beta equals to minus x, okay, and we can write the beta equals to inverse cosine minus x. Okay, and when you add both sides, okay, and that means theta plus beta equals to, okay, pi, so that we can write the inverse cosine x plus inverse cosine of minus x, okay, it equals to pi, okay, and so you can write the inverse cosine x plus, okay, inverse sine x, okay, and it equals to pi over 2. Okay, don't forget these equalities. Because of the, don't forget this right triangle, okay, and this angle is inverse sine x, okay, and this is the inverse cosine x, okay, and that's the x, and that's the y, and that's the 1, okay. You can evaluate from this right triangle, and the inverse of the tangent function, let me continue with it. Of the inverse of the tangent function, and again firstly let's talk about its graph, okay, on coordinate system, okay, and we know that the sine function has asymptote, okay, at the k times pi over 2, okay, and the k starts from 0 to 0, comma, minus 1, plus 1, minus 2, plus 2, etc. Okay, and it has like these asymptotes. Okay, and let me sketch it. Okay, again, and this is the tangent functions. Okay, and let me sketch the other asymptotes. Okay, and these are tangent functions. Okay, and we know that this point is minus pi over 2. Okay, and this is the plus pi over 2. Okay, and this is the goes 0, pi over 2, and this point is pi. Okay, and this is the 3 pi over 2. Okay, and this is the minus 3 pi over 2. Okay, and the blue curve, again restricted tangent function. Okay, and all of them are oops, tangent function. Okay, and it's equal to restricted blue one tangent x function. Okay, and when you restricted it, y equals to tangent x. Okay, for the minus pi over 2 less than x is less than pi over 2. Okay, and that's the domain. Okay, and its range will be minus infinity plus infinity. That's the range of tangent function. Okay, and how can we sketch it? Okay, it's easy. Okay, and now let me sketch the inverse tangent function. Okay, now as you see, these values are the pi over 2 and the minus pi over 2. Okay, as you see, this is the minus pi over 2, and then now this will be the here. Okay, and this is plus pi over 2, and this is the minus pi over 2 asymptotes. Okay, and the blue ones is inverse tangent x. Okay, and this is the inverse tangent x, and this asymptote pi over 2, and this is the minus pi over 2 x y, and the inverse tangent function. Okay, we can write the y equals to inverse tangent x if and only if x equals to restricted tangent y. Okay, and if and only if x equals to normal tangent y. Okay, and the minus pi over 2 less than, okay, y is less than pi over 2. That's the inverse tangent x, okay? And you can write some intervals about these functions again, and what are these? Inverse tangent of restricted tangent x, okay? It equals to same as arctangent of restricted tangent x. It's equal to x, where for minus pi over 2 less than x is less than pi over 2. Okay, restricted tangent of inverse tangent x, or restricted tangent of, okay, arctangent x equals to x for minus infinity less than x is less than plus infinity. Okay, and the inverse of cotangent function if y equals to cot x, okay, and the restricted cotangent function okay will be defined on this interval and its range will be minus infinity to plus infinity, okay, and you can sketch it on the coordinate system again and sketch it easily. Okay, and then firstly sketch the cotangent x, okay, and this is not true, okay, and again okay, and we know that these parts of functions restricted, this is cotangent x, okay, and so the inverse cotangent x will be okay, this point is pi over 2, this is pi over 2, this point is pi, okay, and of course the horizontal asymptotes are the pi and the 0, of course, okay, that is the y equals to arc cotangent x, okay, and My friends, you can look for the inverse secant and inverse cosecant x functions from your book, okay? And this is your homework, okay? And please look at them and learn how to get the inverse of secant and cosecant functions, okay, from your book, okay? It's on your books 210, okay, in your book, 210 pages, okay? And after that, let me give you some right triangle interpretations, okay? And it's important. Okay, and this is our right triangle, and this angle is alpha, and this angle is beta, and this is 90 degrees, of course, and the x, okay, and this point is square root of 1 minus x squared, because of the hypotenuse is 1, okay. So what can we say about it? Sine alpha equals to x, and the alpha equals to inverse sine x, right? And the cosine beta equals to x, right? And the beta equals to, okay, inverse cosine x, okay, and we know that alpha plus beta equals to pi over 2, okay, and so we can say the inverse sine x plus inverse cosine x equals to pi over 2 from the previous equality, okay, don't forget it. And again, another right triangle, okay, this is now alpha, this is beta, okay, and that's the x, and that's 1, and the hypotenuse will be square root of 1 plus x squared, okay, and the tangent alpha equals to x, and the cotangent beta equals to x, alpha equals inverse tangent x, and the beta equals inverse cotangent x, okay, and the addition alpha plus beta equals to, okay, pi over 2, and another interpretation, which is the alpha, and this is beta, and the square root of x squared minus 1, this is 1, and this is x. So secant alpha equals to x, because of secant alpha equals to 1 over cosine alpha, so it equals to x, okay, and the cosecant beta equals to x, okay, and the alpha equals to inverse secant x, and the beta equals to inverse, cosecant x, and the addition alpha plus beta equals to pi over 2, okay, and let me give you an example. if, okay, find the cosecant alpha, okay, cosine alpha, secant alpha, tan alpha, and the cot alpha if alpha equals to inverse sine square root of 3/2. Okay, that means sine alpha equals to square root of 3/2. Let me sketch the right triangle. Okay, alpha and the square root of 3, 2, and then this will be 1. Okay, and we can easily write all of the trigonometric alphas, okay, easily. And what will be cosine alpha equals to 1/2, right? And the secant alpha will be 2, okay? And after that, cosecant alpha equals to 2 over square root of 3, and the tan alpha equals to square root of 3, and the cot alpha equals to 1 over square root of 3. Okay, it's a very easy question. And now let me continue with the derivatives of inverse trigonometric functions. Example, del over del x inverse sine x square, okay, and it equals to del over del x y. It equals to, we know that del y over del x, so y equals to inverse sine x square, okay. So if y equals to inverse sine x square, okay, we can say sine y it equals to, okay, x square, right? And after that, del over del x sine y equals to del over del x x square, okay, and it will be del over del y, chain rule, sine y times del y over del x, it equals to, okay, and the 2x, and this part will be cosine y, okay, times del y over del x, it equals to 2x again. And after that we can write the del y over del x, it equals to, okay, 2x over cosine y. And what about cosine y? Okay, you can easily evaluate it from the right triangle. Okay, and this angle is y, this is x squared, and this is the 1. Okay, so this part will be square root of 1 minus x squared, right? And what can we say about cosine y? It's the square root of 1 minus x squared over, okay, 1. So you can easily, for this derivation, 2x over, okay, square root of 1 minus x squared, which is the solution. Okay, and continue with another example. Right, del over del x inverse tangent square root of, okay, x plus 1, it equals to del y over del x. Okay, so we can say y equals to inverse tangent square root of x plus 1, right? And the tangent y equals to square root of x plus 1, okay? And after that derivation of the both sides, okay, you will obtain the del over del x tangent y, it equals to del over del x square root of x plus 1, okay, and it will be derivation of tangent y will be secant square y, okay, del y over del x, okay, it's equal to 1 over 2 times x plus 1 to the power of minus 1 over 2, okay, and the del over del x x plus 1 inside of the square root of function, okay, and the secant square y del y over del x, it equals to 1 over 2 times, okay, square root of x plus 1, okay, and after that del y over del x, it equals to, okay, 1 over 2 times square root of x plus 1 times 1 over secant square y, okay, and from this part, okay, we can use again right triangle, okay, and this is y, this is square root of x plus 1, and this part must be 1, so hypotenuse will be square root of x plus 2. Okay, what about secant y? It will be square root of x plus 2, okay, because of the secant y equals to 1 over cosine y, so it's equal to 1 over, okay, 1 over square root of x plus 2, so it's equal to square root of x plus 2. So we will use at this side, okay, and the del y over del x equals to, okay, and the 1 over 2 times square root of x plus 2 times square root of x plus 1 times, I'm sorry, x plus 2. So and the second y was that, and this square. Okay, so the total solution will be 1 over 2 times x plus 2 times square root of x plus 1. Okay, that's the derivation of this function. Okay, and let me continue with the another example. Okay, and I'm sorry, del over del x. Okay, and the second inverse second, okay, minus 3x, okay, is equal to del y over del x. So we know that the y equals to inverse second of minus 3x, right? And we can say the second y equals to minus 3x. Okay, and if second y equals that, so we can say the cosine y equals to 1 over minus 3x. Okay, so let's evaluate it, and the y, and this is the minus 1, and this is the absolute 3x, and this is the square root of 9x squared, okay, minus 1, right? And because of the hypotenuse must be larger than 0, okay, we take the absolute value of 3x, and after that del over del x, okay, 1 over cosine y, and so minus 3x, so it will be, I'm sorry, that part must be, of course, del over del x minus 3x, okay, del over del x minus 3x, and after that you will obtain the sine y over cosine square y times del y over del x, it's equal to minus 3, and after that del y over del x equals to minus 3 times cosine square y over sine y. Okay, and we know that from here sine y equals to square root of 9x square minus 1 over absolute 3x. Okay, and when you put these values, okay, and you will obtain del y over del x, it equals to minus 3 times, okay, and the cosine square y, it will be 1 over minus 3x square over, okay, and the square root of 9x square minus 1 over absolute 3x, which is the hypotenuse, and you will obtain the minus 3 over 3 times absolute value of x, okay, and the square root of 9x square minus 1. This is the total solution.